civil engineer, construction engineer, site engineer, design engineer, motivator. Civil site engineers' work ethics, learn how to talk openly, and manage various construction activities at a site. Managing is what most of the time you will do as an engineer. Be super active. The most important thing is showcase whatever you do to your manager, boss. This is what matters at the end of the day. If you do all the work and sit quietly, your increment will be snatched away by someone who is less worthy than you. Forget about being fair and worrying about your body complexion. Prepare yourself to work in harsh climatic conditions, especially talking about Indian weather. Be patient. Never lose your temper. Communicate well, as it will help you a lot in dealing with your client, which is again a tough job. Learn how to write an email effectively, and while writing, choose your words properly, as this will make or break the purpose of your message. Don't tend to panic in case of pressure. It will make things more worse. Civil engineering ethics. If you know well about experiments you do in concrete technology lab, it is good. Even if you don't, no need to worry. You will be able to learn in no amount of time once you start working. In general, engineers don't do survey, it is handled by another special team meant for surveying only. Other than these, there is not much scope for experiments done in other labs, unless you are posted to do works related to geotechnical field. Start working out on general arrangement and reinforcement drawings. This is only main work, which is done by an engineer at the site other than managing. You are supposed to execute whatever shown in those drawings at the site and get it approved from the site. Learn basic functions in Excel, Word and AutoCAD. Have basic knowledge about bar bending schedule, BBS. Preparing BBS mostly occupies most of your lifetime at the site in the initial phase of the work career. Civil design engineer work ethics. Be smart, active. Brush up your communication skills, as you need lot of them to convince many people, like the internal, external checker of your design documents and drawings, client, contractor and site engineers. If you do any mistake or not confident with your design, please convey the same to your superiors, as it can avoid unnecessary outcome which can be catastrophic sometimes. Civil engineering ethics. Learn AutoCAD and STAAD Pro. Note that almost all software used for modeling have the same purpose, it is just that they vary in interface, except some software like Plaxis. Be thorough with code books, mostly concrete and steel codes. There is no guarantee that you will work in a project which uses code similar to what you learned in your graduation. Even though codes of different countries don't vary much, be versatile in getting adopted. Prepare checklist how to make drawings. Even though you will have someone to prepare drawings for you, you must know what all a drawing must contain. You are the one who should have a clear picture about it. No matter how much modeling, analysis, detailed design, documentation you do, at the end, if the drawings don't come out properly, your entire work will go into vain. Drawings speak the entire design. Always read the introduction part of your chapters well. It is not only for civil engineering, but all subjects that you read. I see a lot of people have habit of jumping to the thing they are looking for, important questions that might come in exams, topics they heard someone mentioning in the class, but they would skip the introduction. From strength of materials, learn the various methods of shear force, moment and deflection calculations. Also, for your interviews, remember the basic deflection and moment formulas, like the maximum bending moment for a beam with different end conditions. Deflections for the same, the shape of deflected beam, how is the moment distribution along the beam, etc. From RCC, learn the typical reinforcement details you will have, say for a 2-story RC building, for the various elements viz. Beams, columns, footings. Ask yourself why the Reinforcement is placed at those locations. Learn the clear cover you would require for different environmental conditions. If you are in India, I would suggest to read AS 456 again and again whenever you have time. Also, learn the detailing at the junctions, say beam column, footing column, slab, beam, etc. From steel, one of the things I see students giving less importance is connection design. They are the most important part of the design and therefore should be understood properly. Learn the basic connection details: bolted and welded, beam to column web, beam to column flange, column to base plate, etc. And try to see how the force is transferring. Know the minimum thickness for various welds as per your local codes. Know the basic design methods for seismic and wind forces. Know the costs of steel, reinforcement, in per ton or per kilogram, cement, per bag, or per M3, concrete, per cubic meter, shuttering, per square meter, in your area. Also calculate and see how much kilogram of reinforcement, approximately, per cubic meter of concrete is used up in a normal residential unit. These are questions a lot of people use to ask me in general. Measurements, in both SI units, m, kilogram, etc., and imperial or US units, feet, pounds, etc. And their conversion. Basic things like density, unit weight, of concrete, 150 pounds per cubic foot, 2,400 kilograms per cubic meter or 24 kilonewtons per cubic meter, density of steel, 7,850 kilograms per cubic meter or 490 pounds per cubic foot, etc. Have approximate ideas of lengths of various things. For this, always carry a 3.0 meters basic tape with you and measure various things whenever you have time. With time, you will become good at approximating measurements by just looking at. This comes handy at site. There are a lot other things to know. Learn design software if you are interested in structural design, learn surveying, quantity estimation, highway, road design basics, etc. Be curious. When we're designing components of a structure, beams, columns, we often calculate the area of steel reinforcement asked to be provided in the various zones: tensile, compressive, and shear, but we do not pay adequate attention to manifesting this asked in terms of bars of so and so diameter. It is extremely important for a designer in practice to make sure that the bars provided are such that it is practically feasible to give such an arrangement at the site. Especially at the beam and column beam joints where poor choice of reinforcement distribution will result in congestion at the cross-section. This will inhibit the coarse aggregate from depositing into the junction and only the slurry will be able to flow through. Read AS codes related to work in progress at your site. For this, Android phones are handy. Another major problem is that proper compaction of concrete, which is often done using a needle vibrator, will be extremely difficult to achieve when the reinforcement cage is congested. This will lead to defects like honeycombing or much serious voids within the junctions, as compaction of con rate at such junction will be difficult. All this will ultimately make the beam-column junction far weaker than it's designed to be. Moment releases and load transfers that are worked out during the design stage will not be achieved, and this poses a serious liability on the structural stability. It is important for us to remember that calculations worked out on a piece of paper will mean nothing if we are not able to correlate them with practical conditions. There are already some good answers to the question, however I will let you know from the project management perspective as a whole. You will definitely head start your career on site if you are serious for this profession, and you can make a good project manager only if you know how to answer questions relating to the project as a whole. A person who is putting his money in, be it your company or a client, will only be interested in knowing is how much time it will take to finish and what will it cost him, in a small summary. The first thing you should be able to answer is how much time any activity and the project as a whole will take to complete. You should be able to break down a project into a level 1 WBS mentally and assign duration at that level. Study the schedules of complex projects and you will get some understanding of the time it takes for a group of activities to finish. The other major consideration of any project is the cost involved, and this is the most important criteria for taking up any activity in a project. I believe that every other thing finally boils down to the cost involved in a particular project. So every decision you make, whether what quality you want in your project, how much safety measures you want to implement, how much time you want to keep the project running for, are all related to how much will it cost me. The person investing in a project is never bothered about how you will do a project. That's why he has hired you for your technical competence. The only thing he will want from you is how much it will cost him and how soon you can deliver him his money's worth. Observe everything, know how to study people, their attitude, their presence of mind, decision-making skills, problem-solving skills, and their managerial skills. Give attention to detail. Learn to study the drawings. Be familiar with the code, mainly for RCC and steel. Know the softwares: AutoCAD, STAAD Pro, Revit, MSP, etc. Have a practical knowledge. Pure technical knowledge isn't sufficient. Don't procrastinate things. Not even simple things which takes minutes to complete. Learn to prioritize things. Know where to start, which work to complete first. Complete all works with perfection within the stipulated time. Learn to multitask. Don't disappoint your manager. Greet him, her with smile. Do the works given by your manager first. She is going to look after your promotion. Work on your communication skills. Know what to do, when to do, how to do. This comes with experience. If you are into site execution, know these facts. They'll be useful forever. Like, for example, dimension tolerance for cubes plus 2 mm. Maximum free fall of concrete allowed is 1.50 meters. In soil filling, as per as code, for every 100 SQM, 3 sample for core cutting test should be taken. Read a lot to be in the know. Cement shall be stored in dry places on a raised platform about 200 mm above floor level and 300 mm away from walls. Bags to be stacked not more than 10 bags high in such a manner that it is adequately protected from moisture and contamination. Water used for both mixing and curing shall be clean and free from injurious amounts of oils, acids, alkalis, salts, sugar, and organic materials or other substances that may be deleterious to concrete or steel. The pH shall be generally between 6 and 8. Cement shall be tested for its setting. The initial setting time shall not be less than 30 minutes. The final setting time shall not be more than 10 hours. Out of many facts, I found the above very useful. The practical things a civil engineering student should know also depends on the future plans of the student after completing his/her graduation. If going for a job, most undergrads are recruited by construction companies in the country. As a field or design engineer, the following must be on the tip all the time. All field and lab tests for cement, aggregate, sand and concrete. Lab tests of soil, both surface and foundation soil. Proficient use of all the surveying equipment, including auto-leveling and triangulation devices. Good knowledge of codal provisions of RCC structures and steel. Design parameters of both vertical and horizontal curves during road construction. Length to height ratio, thickness of the wall and area of other rooms while designing a building. As an architect and/or cost estimating engineer, the rates of construction materials. Furnishing materials, knowledge of tenders and contracts, cost of labor and wage. Management, cost estimation of a building project from foundation to furnishing. If going for further studies. Command on all the design parameters and basic topics of the subject you're going to take. For specialization, e.g. if one is going for transportation engineering, definitions of PIEV. Theory, setback distance, SSD, joints in pavement, signaling in railways and highways. Windrows diagrams, etc. must be expertised at the time of undergraduation itself. At least 2 methods for the calculation of moment and displacement in beams and columns. This is for every civil engineer actually in field or design. Also, knowledge keeps you ready for interview. In a nutshell, the practical things a civil engineering student must know are: lab and field tests of building materials, basic knowledge of soils and their properties, methods of force, displacement and moment calculation, tests like pH value, acidity, basicity, amount of total dissolved solids (TDS), etc. in water. Without water there is no construction. You must know the standard formulae of RCC and steel structure design. Properties of fluids, water, to be precise, in laminar flow. Use of theodolites, leveling machines and other surveying equipments. Advanced skills in mathematics, including algebra, geometry, trigonometry, calculus and statistics are crucial to a civil engineer. You must apply the appropriate mathematical formulas and principles in your design work as well as to problem solving. As project budgets and costs are an integral part of your responsibilities, you must also be proficient in reading and interpreting financial spreadsheets. You must be highly skilled in physics and the practical application of scientific rules, methods and the technology involved in the many aspects of the project, including design principles, construction methods and materials, soil analysis, and numerous environmental factors. It is also important for a civil engineer to be skilled in architectural design techniques and working with blueprints, maps, drawings and models, as well as computer programs used in architectural design and construction. Wear all PPEs on site. Follow safety rules. Give safety first priority.